What is the first thing that you should be doing as you come to class? Plan book. We got to get in these habits. I really, especially with how we're adapting this year, and I will not necessarily always be using the computer, I do not plan on posting your homework up on the board. It's up over here. It's here like the whole week. I will strive to have the entire week's homework figured out by Monday, but this week was awkward, and I couldn't tell how quick we were going to be going. There will probably be homework tomorrow. You still have AO tomorrow and everything else. Not much, not a big assignment, but there will probably be homework tomorrow. So, I left you with a situation and a question yesterday. Can anyone remind us of our situation, our question, or whatever was going on? Name tents, please, guys. Go ahead and get your name tents out. Now I'll call on you, Annie. All right, Annie, what was our question?
The question was, if you had a million pennies and you stacked them up, how tall would they be?
So our question, and be careful as we start working, there's a couple dimes hidden throughout here. Those are outlier variables. I did that on purpose. So we started stacking, and I stacked a stack on top of the stack. We left asking how many pennies, how tall would a million pennies? So now I want you to think relative to some other values. So what you need out right now is just your math book and your math journal. Every day in class, probably assume that you're going to need out your math book and your math journal. So in your math journal, go ahead and open to either the last page you were working on or the next blank page. And I want you to label it with today's date. So, what is today's date?
The 24th.
24th. So 1.1.4 is what we're doing today. It is 8/24/17. And today's lesson is how big is a million? I just stick it on the stack. Yeah, go get it quick. It's easier than... And then write down 1 million with proper commas and decimal. 1 million pennies. I will occasionally, you'll see that I learned cursive. So a lot of times I'm writing like half in cursive, half in print. So apologies on that. I also have terrible handwriting. I actually write better on the board than I do on a flat surface. My smart ink is just kind of broken right now. So I want you to talk with your group and approach these couple of questions on 123, which you don't need to open your book. I'll put them back on the board. So we're right here. Would a million pennies be taller than Phoenix? What you're going to discuss with your group? Would a million pennies, well, Phoenix is easy. Would a million pennies be taller than, let's say, Kilburn? Would a million pennies be, say, taller than the Rhodes Tower downtown, which is a 40-story building that the firefighters and the police officers every year have a competition running the stairwells? Would it be taller than a 40-story building? Would it be taller than Mount Everest? And Mount Everest is 29,029 feet. Very cool story called Peak over in Mrs. Goldring's room about a young boy climbing Mount Everest. So if you're interested in climbing. So discuss these problems with your group and write some things down in your math notebook. And you can just put like school, yes or no, like Kilbourne, yes or no, Everest, yes or no. Because we already wrote down a million pennies. So we could say in our math journal, a million pennies taller than. So we could say like a million pennies taller than. And then we could say like school, or you could say Phoenix. And then write whether you think yes or no. Everest. And then I want you to actually make a prediction. How many feet tall do you think it would be? Or, if you're like our friends across the pond, what do you think I'm going to offer up? Instead of using feet? Meters. Talk amongst your groups. You do not have to all agree, but sometimes discourse is a good thing. So you don't have to agree whether or not you think it'll be taller than Everest or whatever, and your predictions don't have to be the same. But it's beneficial to talk amongst each other to figure this out. Then, especially if you disagree, start to discuss what strategy could you use to figure this out. I'll give you at least 3 minutes.
Probably. Why do you smell good? I'm going to be wrong. Why do you Oh, hey! I got it. Well, is he getting I got one. You could have asked.
Hey, gravity did the work. I just let go. So, alright, you can pick it up. Yeah. You can have one. Your group can have one. No. No. You don't have pennies yet.
Well, but we don't have a
Ah, get back.
What me?
Oh, you already picked
How big did you say? 10 pennies.
Let's not do it. We'll take a try to measure ours.
And measure it.
It's not exactly.
Keep it almost in the same
It's not so clear.
What is it?
Good for people. If you're doing something.
It's to hurt yourself. It's about 1 million centimeters tall.
Okay, a centimeter is about less than half an inch.
Not yet. And actually, I don't know if I'm going to let you here. I mean, all right, let me bring you back for just a second. I want to get a count. How many people think a million penny stack would be taller than Phoenix? So we have, is that actually a no vote, or are you just still frantically writing? You don't have a vote? All right, so we'll leave you as undecided, but we have 18 yes and 1 undecided. What about Everest? I think a million pennies would be taller than Everest.
I think yeah, sure.
One yes. Everybody else. How tall is Mount Everest?
Okay, whatever. Couple thousand.
Yes.
All right, so keep discussing how you could actually try to figure this out. Your prediction as active. Careful about the lines.
So, 10, I said 10.
No, there's stacks. Not balanced stacks. I'd rather you not, but if you absolutely have to, fine. Grab it.
I did it, my
I
mom.
know. That's awesome, though.
I was like scavenging my
Sure. That's awesome. I get excited over small things like that, too.
I once got uber excited because I was told everything against math. I did all the math. 1.5 wait, it's not even 1.5 centimeters, Will.
Okay,
It was 1.5 centimeters.
Yeah.
This is a centimeter. I know. I said centimeter. So 100. Why are you doing it like that? Like this? Yeah, put it like straight up. Or like this? That's how you
okay,
probably
it's like,
So. Never mind. Ignore me.
0.25.
This would be like a centimeter 45. This would be
like
You may use a calculator at that point where you feel like that is necessary.
That's I thought that'd be like really weird in my life.
So it's like
No, 1.05. I ate it.
well,
Hey, I ate pizza. I ate
so
pizza.
obviously there's a little
Hey, I once ate.
so that's like if you
I once
get this,
ate, like not as paper.
let's just count that
I actually
as
ate paper. I love a printer.
0.25 centimeters. So this right here, this is right here. So I think it's about either 0.25 centimeters or 0.5 centimeters.
Zachary is hard.
So it's like,
Have you done how's this? I think. Hey, give me my calculator. I did something to my calculator. Oh no, I'm sorry. Get all the germs.
okay, so
What do you have?
okay, so what do we think it is? I think it's like
I'm gonna stack
1.5 centimeters.
How many
1.5 centimeters. Okay, so then 1.5 centimeters equals 10. So, what we do?
Alright, I want you in your math journal to label penny conversions or penny conversion factors.
1,500,000 centimeters.
So what I find interesting, did you ever go home in previous math classes, and this might be a question that I get wrong, did you ever go home and do more homework than your teacher asked you to do? Yeah. Okay, well, see, you're the accelerated class. But it's funny because some of you actually went further than I even wanted you to do last night, and you came with your own cheat sheets or conversion sheets or whatever. And this is funny because I was talking to Izzy. She said, I was trying to figure this out, and then I found a bag of pennies, and I got really excited. Why did you get excited that you had found a bag of pennies?
Because then it would be helpful to find how to get up to 1 million pennies.
Why is it helpful? What did you do then?
She stacked them. I stacked them.
Okay, so you stacked up 1 million?
No, not 1 million. A lot. She stacked
Okay.
up 3.
Hey, Will, are you Izzy?
No.
Thanks. She can speak for herself. So, what'd you do last night then?
Just stack some pennies on top of each other.
And measure to get what? What did you? Were you trying to? Did you have a certain number of pennies or a certain height, or like what was your strategy?
Number of pennies.
Certain number of pennies. So, what did you do?
I measured 10 pennies and then I took 1 times and get my
10 pennies. Okay, so hold on. So let's say, and you can do this all at your table groups. Be careful because your tables are slanted. But so measured data. We have that 10 pennies. And actually, I'm going to put 2 different equals here. I'm probably going to do some American measurements and some metric measurements. Because I don't yet know which one is better. So if we stack up 10 pennies, you don't tell me how tall that is. And be careful, your ruler doesn't start at 0. careful, your ruler starts below 0. So if you set your ruler on the table next to the pennies, that is not accurate. So let's look at this so we all know what I'm talking about. At your table, you should have a ruler. If I look at the side that is inches, notice the start of the ruler starts below 0. If I look at the side that is centimeters, the start of the ruler is not your 0. So you have to be very cautious when we go to measure. What's something that I could do to measure 10 pennies but not have to set it like stacked up on the table? Annie, what do you think?
You could lay like your ruler down on the table and then take 10 pennies.
Ooh, so I could go 10 pennies wide. Can I borrow some pennies from somebody? Anyone have extras?
I have
Does this count?
just take them.
So 1, 2, 3, 4, 5, 6, 7. Yep. So because I've got the metric side right here, I'm just going to use my metric side. I've got my 10, right? And if I had some tools at home, I'd probably throw these in a vice grip or something. And I'm going to measure, so I'm going to line up my 0. Where does that go to? So 1.4, or we could actually say 14, or, right, how do centimeters and millimeters work together? So we get, so what are we going to say? 10 pennies equals what?
14 millimeters or 1.4.
So we can do centimeters if we want, and we can convert later. Or we could do millimeters. What about inches, though? So if we try the American method, this is actually easier if I look at the computer. So remember, this is my half-inch mark, the big guy right there. Is this easy to tell? It's past my half-inch. But the fractions are awkward, right? So it's like a half plus another, is that like a 16th or a 32nd? Or one thing I want to get you to understand. We're a bunch of cowards. In 1970 something, maybe it was late 60s, early 70s. If you're sketching or not paying attention, I'd love for you to give me a second because this is actual real stuff that happened. The whole world said we need to get on the same page. We gotta be standard, right? We're together, right? We're one Earth. America signed something called the Treaty of the Meter. Anyone ever heard of this before? No. Okay. We agreed, like the rest of the world, we are going to switch to the metric system. What's speed measured in? Miles per hour. Distance, miles. Track, feet. Like yards. All of that, American. Not metric. We never switch. We signed the treaty. You can look it up. It's literally called the Treaty of the Meter. Like a treaty where you agree to stuff. Treaty of the Meter, we bailed. We backed out. We cowered. It would have cost a lot. We'd have to switch all the road signs. So we often in America use American standard. Inches, feet, yards. Math class, though, I want to make your life easier. Inches are tough. Fractions are tough. 16ths and 32nds and 64ths are tough. What's easy is decimals. Tenths, hundredths, thousandths. Easy conversion factors. We are going to default to using metric. Okay? So like this 10 pennies is a good example. It's less than an inch. It's some odd fraction. I give up. Use metric. Just use your metric. So I got 10 pennies equal 1.4 cents. What other, anybody else have any other conversion factors for me or any other measured data, anything you figured out? Did anybody, yeah?
I have that, what I had
Okay.
pennies is the thickness.
Now, if you're predicting based off 1 penny, how big will an error be when it comes to 1,000,000? It'll get pretty big, right? That error would make a big difference. Gravity.
That's why you take the extra units for it.
So sorry, hold on, speak up. I can't hear you. That's why we what?
That's why I mostly have the actual one because that one I'm going to check with it and see how far off it is. But also what you can do is you can take the amount that I'm off in millimeters and you can do the same thing I did with the other one, with the extra that I have too much of. And then you can just, when you get to the same amount, you can subtract that from that one and you have the exact answer.
Okay.
Everyone, because the two is easier to.
Do me a favor. Let's make a T-chart. T-charts are fantastic. They're our best friend. So let's make a T-chart involving height. And we're going to label this centimeters. Let's just work in centimeters. And number of pennies. T-charts rock. Now we have 1.4 centimeters. Took 10 pennies, but that's nice on the penny side, awkward on the height side. We chose 10 pennies. What if instead of choosing the number of pennies, I choose the height? So I want you guys to start to fill in this T-chart. I would first advise you, try how many pennies would it take to get 1 or 2 or 3 or 4, depends on how high a stack you can make or how long of like on your table you can make. Then could we use that, I don't know, maybe we go to 5 because 5 is a nicer number. And then maybe we use that to, I don't know, get to the height of 10 centimeters or 20 or 30 or 100, because then that's going to be a meter. So play with this. Instead of because are you going to end up with a portion of a penny? Probably not. You can round. So if I choose my heights, my pennies are going to be integers. So try that out. Play with that for a little bit. And you do not necessarily have to measure each and every one of these.
So all we need to do is pennies equals 7, and then we just add it to then how many.
Also, it's not exact because it's one consecutive
Because you're using the calculator.
Well, let's
How are you sure about this?
well, let's see.
Did you physically measure 1, or did you measure more than 1? How? You have my collar? How do you know 1.52? You're accurate to the hundredth place. Well, I'm not talking about the other project. I'm talking about today, right now. How do you know? Right now. How do you know? That doesn't exist.
So we're not using it right
You come back to this. So, forget about that. You can't use stuff that you found out in other places. So, what I see is you don't have the T-chart that I just asked everyone to know. So I think you're not buying in what I'm trying to get you to do. So forget about previous projects that you've done. Trust me here. Work with me to do it through this method. Because I don't know exactly how you got to this. We're going to try to do that. But you can't physically measure a penny and think that unless you have my micrometer. With a ruler, I can't measure 1 penny. It just doesn't work. But I could measure 1.
Right now,
I can measure 10 pennies, but 1 is just too small. So play with that T-chart, see what value you can get.
it's not like, so this is like the generic haircut that I always had. If it wasn't this, it was like this.
Once you find a proportional relationship, you can just multiply.
Okay, and so where did I go? Oh, it's right here. Okay, so we think this is 7 pennies. So if we want 2,
So 1 penny equals 1.4
then
million.
so 1
What are we pennies?
35, and then 7 times 6 is
One penny, 7
7
centimeters.
times 7.
How did
So
you
Big
get 7?
penny.
You are
7.
very fast. How did you get 7?
Okay, 7 is what
That doesn't sound
is what Izzy and me
That sounds like
kind
you
of
just
calculated
Yeah.
together. What
Can you
is
accurately measure what one
Basically,
penny
look,
is?
no, look at it. 1.4 centimeters is 10 pennies.
And if
No.
if they all have slight variance,
7 centimeters.
what can we do to
Oh, one
find
One's
the
half centimeter.
average? What do we have to do to find the average?
So,
Not all, but work with many. So if I wanted to find the average height of a 7th grader, I couldn't just look at you. I have to look at myself.
I'm pretty sure.
3, and then 7. So, we think that the number of
Census data.
7
Seriously. Look up the US
7
Census. They have data on the penny.
This class is short for 7.
I heard a lot of really good conversations as I walked around. Let's bring it back together for just a second. I'll release you again. So, if you were looking in your book, this is actually problem 1-25, so I would off to the side somewhere label that we're working on problem 1-25. So, I asked you guys to forget about a specific number of pennies and work with specific measurements. Anybody have any data that we can fill in our t-chart with? Annie, give me some.
100 centimeters is 700 pennies.
Whoa, did you stack 700 pennies?
No.
So, come back up here first. Give me some measured data that you actually collected. Rachel?
1 centimeter equals 7 pennies.
7 pennies made up 1 centimeter. Now, was your 7 penny stack like you actually stacked 7 pennies? That should be IES.
Yeah.
Wow, I'm terrible.
Yes.
Okay. Now, I want to check if that actually holds true because I had a conversation back there with Ian about how, well, there's maybe some slight variance in the size of the pennies. What could we do? We can kind of average them. We can look at groups. So to check that, I could do another measured data of what? If I did 1 centimeter, what could my next measured data be? 2, right? Do you think I could stack 14? If this is true, 14 pennies should equal 2 centimeters. Did you guys check that? I mean, we stacked 10, right? 10 was easy. We did 7. Let's try 14. Check, is 14 2 centimeters?
So, you have to calculate Alex, you have to calculate. So we need to multiply 70.
So, what you should be finding is that it works.
Oh, you just said that.
So this works. Now, Andy, explain to me how, because you just wanted to straight up give me 100 centimeters, which is like this tall, because I'm about 2 meters tall. I don't think you're going to stack pennies that tall.
Can we try?
How did you get that? I mean, you told me 700, and you seem pretty confident. How'd you get that?
Well, 1 times 100 is 100. So I did 7 times 100 is 700.
So you recognized something. You recognize that the height and the number of pennies are going to have what kind of relationship?
Well, yeah, I know, but 1 times you just multiplied 7 times.
So what we actually found, and this is where your math notebook, like colors, bless you, colors can really come in handy. This T-chart actually shows me, and I would love for you to write this in your math journal because it will help get it in your brain. Anyone know where I'm going with this? Proportional. This is a proportional relationship. That's how Annie knew, well, I can just multiply by 100. And that, if I do that to go from 1 to 100, is the same that I do to go from 7 to 700. So, if you were moving on in the textbook, because I'm going to label as if I was, the next question is 126. So if you want to label that this would actually be 126. So we now know that 100 centimeters equals 700 pennies. Right? We cool with that? We all agree? But the problem is, working with 700 is awkward. Right? It's kind of like, we got to get to 1,000,000. So one of our classmates comes up with a really good idea. And they said, you have your textbooks open. I'm intentionally not having you guys look at your textbooks because a lot of you will look ahead, not wanting you to do that. So one of your classmates thinks, well, okay, so if we need to get to 1,000,000, 700 is not that easy to work with. What would be a lot easier to work with than 700? Somebody said 1,000. Can I easily go from 700 to 1,000? Like some kind of proportional, like, if I add 300 pennies, I'm going to have to add the height relative to 300 pennies. That's kind of weird. Annie?
You put 1 centimeter.
Oh, sorry, that's 1 meter or 100 centimeters. Sorry, I totally wrote that wrong. Thank you for paying attention. I get caught up with what I'm saying, and then what I'm writing doesn't come out correct. I want to get to, eventually, I want to be able to say what 1,000,000 pennies equals height-wise. So Ian just said, couldn't we go to 7,000,000 and then just divide by 7? Yes. Or turn the order of what you just did around. Could I right now? So an easy way to get to 1,000,000 is to start with 100. Here's your challenge. How tall would a tower of 100 pennies be? Use that to get you to the height of 1,000,000. Go for it. Be careful, you want to be very accurate here. We're working with 1,000,000. You want to be as accurate as possible. Keep those decimal places.
Okay, so to get to 700 to 100, we need to divide by 7.
So there's actually a 7. So 14, 28, 57. Okay, that's what
Look at the board. Look at the board. Which one did you get?
14, 28, 57.
So 10 times 10 is 100. So 1.4 times 10, which is 14, is 100 pennies in 14 centimeters tall.
So, yeah, we're trying to get 128 pennies.
They all
100 pennies.
14, 28, 57. They start at a different number every time, but they always have the cycle 14, 28, 57.
And be in a group.
Mind blowing. That to me is gorgeous. That number relationship, that's gorgeous. That's beauty.
Unfortunately, in algebra, what we can is much teamwork. So you're going to have to bear with us.
So wait, how did you go from 700 to 100?
In California.
So how would you go from here to there? So explain it until they get it. You might need to rephrase it. How we doing?
Centimeters
Okay, yeah, I like it. So how'd you get to the 14.8? Okay. So how can we figure out how to go from 100 to a million?
Sorry, I was multiplying.
You can figure it out through division.
Yeah, this is what I forgot. Because it's in centimeters. So,
I mean, we're gonna end up trying to round to the nearest like meter. I think.
forgot to put this.
So right now you're getting your answer in centimeters. So then we'll do a little conversion.
I think he's smart.
Let's know.
You're a murderer. But that you got. No, listen. That was in my pad. I thought it was different at all. I wasn't allowed to. Yeah.
All right, let's bring it back together because I fear I'm gonna run out of time here. So actually, I think almost every group was able to tell me as I came around that to go from 700 pennies to 100 pennies, you realized you had to divide by 7. So you took your 100 centimeters, divided by 7. Keep your decimals, please. If we're working with a million, you want as many decimals as possible. So that 100 pennies equaled what height? You had, what do you got, Oliver?
14 centimeters.
No. You're close. When I multiply that by anything, I have dropped all of this information. If you round that, you've lost a ton of info. Annie?
14.285771429.
Ooh. So, Naya, you had your hand up too. You guys had the same answer, right? The 14, 20, Jen had got you guys through that. So then, if we want to go from 100 pennies to a million pennies, did you guys get that far, Naya? So how do you figure out what you're going to multiply by here? Because we know we get bigger. We know we got to multiply. Talking with you, Naya, if you want it. Because you have your hand up. Times what? Ooh, so I talked with another group, our group right here, about if I don't know what to multiply by. I know I got to multiply by something to get bigger. I know it's a power of 10, so I go from a power of 10 to a power of 10. If you ever don't know what to multiply by, what do?
Divide.
We divide. So you can take your million divided by your 100, and actually you just chop off 2 of the zeros, and I end up with 1 with 4 zeros. 10,000. So 10,000 is what we want to multiply by. So you take your 14.28, yada, 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 yada. And we multiply by 10,000. Now, Annie, you just said move the decimal point. How do I know how far I move the decimal point? How many zeros we have is what tells me how I move my decimal point. So I have 4 zeros. I'm going to move this 1, 2, 3, 4. And my new answer becomes 142857. Then my decimal point, 0.1429. We'll end up rounding. And that is centimeters, right? So that can actually go over here too if we wanted, but I kind of shifted my work over to the right-hand side. So let's add your commas to get some specificness. 142,000 centimeters. How do I make centimeters into meters? How many centimeters are in a meter? Alex, right?
Yeah. There are about 10 centimeters.
Close.
Oh, 100.
Yeah, centa means 100. So I can divide this by 100 or move my decimal back 2 places. That converts me to meters, and I get 1428, then my decimal point, 5714, I'm going to round that, 3, and that's meters now. So we get 1,428 meters. Anyone know, and I only know this because of swimming, anyone know how many meters are in a mile?
Like a million. Isn't it 1,600?
Approximately, I forget how close this is. There are 1,600 meters in a mile. So this is almost a mile tall penny stack.
Wow, pretty dang tall. That's
Pretty crazy.
That's when they go around the earth.
You'd have to have some really good balance for them.
Or you could just get like a tiny little box. Or you could voice people up.
All right, so crack your textbooks really quick. I got 2 minutes left to chat with you really quick. I want to give you a couple extension opportunities, and then your homework is obviously 35 to 39. Should have written that down when you came into class. 35 to 39 is your homework tonight. Check out wherever 1-30 is. Somebody give me the page, so I'm in a different book.
Somewhere.
1-30, okay, page 18. So, like I said, with us being Accelerated 7, we are not always going to go completely through everything. We're going to kind of skip through things kind of quickly. Some of what we've talked about today, some of what we did, and we kind of did it quickly without, like, kind of going through the textbook step by step. When we wanted to compare with Mount Everest, we know Everest's height in meters. So, if we want to make our life easy to compare, we took our height of centimeters, made it into meters, so that we could then compare. Look at your textbook. How tall is Everest? Almost
8,800.
Yeah, almost 9,000 meters. Is our penny stack anywhere close? No. Everest is the tallest mountain. Well, one of the. I forget if it is the tallest mountain on Earth. I think it's one tallest. Yeah, there's some weirdness. So check out those problems if you want, because those go through what we talked about. 131 talks about accuracy. If you had just rounded, I forget what group it is, told me, yeah, our 100 pennies is 14 centimeters. If you had left that at 14, this answer would have just been 1,400. We would have been 28 meters, which is pretty far off in our result. Hey, Will, can you sit down and chill, dude? I don't know what you're doing, but it's really disrespectful since I'm trying to talk and teach and you're over there screwing around. I don't want to have to be talking to you about this. That would have been 28 meters off. Now, most of you would say up here, well, these decimals don't matter that much. But they end up mattering a lot. So be careful with rounding. 132. We could play with this even more if we know how tall, like we've got that proportional relationship. We could extend that to 10 miles, and we could keep going. So then if you flip the page, 135 through 139 is your homework. That review and preview section, all right? If you want to leave your books in here, give me a second to move this shelf really quick. But we are giving you probably noticed when you came in, this second shelf over here, it's going to be right here. Second shelf down is going to be your guys's, so that if you need it during AO, you can come in without really coming that far in the room. You can slip right in, grab your book, and then that's that. What's up, Penny?
Do we do this in our master room?
In your master room, yep. And aside from that, you guys are good to go.
Thank you.
You are welcome. So if you don't want to leave your book here, you're fine to leave. If you want to leave your book, give me a second. Oh, please put the pennies back in my black cup of pennies up here. Please put the rulers back where the rulers go. You want? All right, second shelf is yours if you want it. You are welcome. Rulers? Oh, she took the black cup. So you can separate it. Thank you guys. Have a wonderful day. I'll see you later.